Once you've done your recrystallisation and you've got your hot filtrate, this needs to be cooled to room temperature. If you want to do this quickly, you can use an ice bath. However, you'll get better crystals if you allow it to cool down slowly. If you do need to do this quickly, then use an ice bath. Immerse your flask in the ice. If you want to leave this for a while, make sure you clamp your flask. You can see the crystals are already coming out of solution. Make sure you allow the filtrate to cool to room temperature or below. The crystals can then be collected by filtration. It's a good idea, however, to keep the filtrate just in case you don't get a good yield. We're going to use a Buchner funnel to collect the crystals. Turn the water aspirator on full and connect it to the flask so we apply a reduced pressure to the flask. Make sure the funnel is well sealed. You can use a few drops of the solvent to seal the filter paper. Then carefully pour a small amount at a time of the filtrate containing the crystals into the middle of the filter paper. You can use some of the cold solvent to rinse the flask. Swirl it around to try and get the remainder of the solid out. You can now use a small amount of the cold solvent to rinse the crystals. Don't use too much though, as you'll start to dissolve them. Take the tubing off the flask before you turn the tap off. Otherwise you'll get water sucked back into the flask. If you've got less material, you could use a Hirsch funnel instead, which works on the same principles as a Buchner funnel. You've got a filter paper covering the holes in the bottom of the funnel and a side arm which is attached to the water aspirator. Obviously the volume for the filtrate is a lot smaller, so you need to make sure you're not filtering too much. Once you've separated your product, it's a good idea, if you have time, to dry it in a vacuum desiccator. Carefully remove the filter paper from the Buchner funnel. Place it onto a bigger piece of filter paper and sandwich it between another piece. Then turn the edges over to make a parcel. It's a good idea to do this because when you come to open the vacuum desiccator, after drying the crystals, they can easily be disturbed by the airflow through the tap whilst the pressures are equalising. This is a vacuum desiccator. If you take the outside cover off, you'll see that there is a drying agent in the base covered by a metal gauze, which is where we're going to put our compound. You can use a variety of drying agents, but this is anhydrous calcium chloride. We're going to put our compound on top of the gauze and put the lid on. What we're going to do here is create a very dry atmosphere using this drying agent under reduced pressure. Because we're going to do this under reduced pressure, we need to put a cover over the desiccator. Turn the aspirator on. Make sure the tap is open and attach the tubing. Leave this for 5 minutes or so. Close the tap. remove the tubing and turn the water tap off. When you come to open the desiccator, make sure you open the tap slowly so the flow of air back into the desiccator is slow. Once the pressure is equalised, take the cover off. Remove the lid and take the crystals out. The crystals should now be dry and ready to have a melting point taken or further characterisation.